So we're going to find the zeros of this polynomial, all the complex zeros. It's a fourth degree polynomial. So according to the fundamental theorem of algebra, there should be 4 zeros. We're given one of them, 4 plus I, so we need to find 3 more. Since it's a fourth degree polynomial, with synthetic division, we'd have to break it down twice to get a quadratic that we can handle. But one thing that helps us out here is 4 plus I is a complex zero, so its complex conjugate, which is 4 minus I, must also be a zero. So now we already have 2. We're going to do this with synthetic division, and the calculator is going to make this very simple for us. So we're going to use that first zero that was given, 4 plus I, and with synthetic division, we should find that we will get 0 as the remainder, as always. I don't know why I wrote the plus there, but so here we go. You want to do this all with a calculator because the storage on the calculator is going to help us a lot. So I'm going to do that right here. Hold on a second. I want to make this so we can see it. All right, so here we go. I'm going to start by typing this. One second here. I want to make this easier for everybody to see. There we go. So I'm going to bring down this 2, and I'm going to multiply that by 4 plus I. So 2 times, always put your complex numbers in parentheses. That way you won't have to worry about making a mistake as far as that goes. And that's obviously going to be 8 plus 2I. So we'll write it right here. And then we add a negative 13, so plus negative 13. So you can see I'm going to do all this on my calculator. It's going to be pretty simple. Negative 5 plus 2I. Negative 5 plus 2I. And now I have to multiply this answer by 4 plus I. So I'm just going to hit times. And then 4 plus I. And this is going to be very simple after this. So I have negative 22 plus 3I. And you add that, I get negative 11 or plus 11. Hold on, let me do this on the calculator. Negative 11 plus 3I. And I have to multiply this by 4 plus I. But I already have that on my calculator. You can see the answer times 4 plus I. So I'm just going to select that so I don't have to keep typing that. And it's negative 47 plus I. And then add that to 43. That's the next step. Negative 4 plus I. And then multiply that by that answer by 4 plus I again. And I get, hopefully I get negative 17, and I do, so we're good. So that's how you would do it on the calculator. I'm going to expand this a little because it's kind of messy because that screen was so small. So that's that. And now I'm going to use the conjugate 4 minus I. And I should still also get 0 because 4 minus I is also a 0. And you're going to do this with the calculator as well. I'm going to just try to do it by mentally here. I have 8 minus 2I. I add, you get 3. Then multiply, you get 12 minus 3I. This is not so hard to second time around. You can easily do this mentally. You add this, you get 1 plus 0, and then 1 plus 4 minus I is 4 minus I, and you get 0. So the good thing about that is now we did this twice in a row, and we stacked them. So this is a quadratic, which is 2x squared plus 3x plus 1. And we're going to solve that either with a quadratic formula or by factoring. This does factor. 2 times 1 is 2. There are factors of 2 that add up to 3. So this should be an easy factoring problem. I'm going to also do this mentally. We're going to have a 2x and an x to get that 2x squared. And then we also need a 1 and a 1 to get 1. So that's really easy. Just FOIL it out. Make sure you get that 3x in the middle. We will. So my other two zeros are x equals negative 1/2 and x equals negative 1. So my 4 zeros, which I should get because it was a fourth degree polynomial, are 4 plus or minus I, negative 1/2, and negative 1. Now, when you graph this, obviously you won't see the imaginary zeros on the graph because they're imaginary and the graph is real numbers. So you will see a graph that goes through negative 1/2 and negative 1. So that's that.